Time is something we all think we understand, and yet it remains one of the deepest mysteries of the universe. We live inside it. We measure it with our watches. We celebrate its passing with calendars, and we carry its weight in our memories. But what if time is not as rigid as it feels? What if it bends, stretches, or even loops? Could we one day travel through it, stepping out of the present and into the past, or into a future that has not yet arrived? This is the dream of time travel. And while it has long been the stuff of myth and science fiction, modern physics has revealed that time is far stranger, far more flexible, and far more fascinating than we once believed. The story begins with Albert Einstein. Before Einstein, time was seen as absolute, ticking along the same everywhere in the cosmos. But in 1905, Einstein unveiled his special theory of relativity, and with it came a revelation. Time is not universal. It is relative. It flows differently depending on speed. The faster you move, the slower your clock runs compared to someone standing still. Imagine boarding a ship that races close to the speed of light. On board, everything feels normal. But when you return home, you may discover that decades have passed, while you have only aged a few years. This is not a fantasy. It is a real consequence of relativity. Time travel to the future, in this sense, is not just possible, it is inevitable. But Einstein did not stop there. In 1915, he expanded his ideas into the general theory of relativity, showing that gravity too affects time. Massive objects bend the fabric of space and time, slowing the flow of moments nearby. This effect is so real that engineers must account for it when designing GPS satellites. Without corrections for gravitational time dilation, your navigation system would be off by miles in just a day. In other words, without Einstein, your smartphone would be lost in space. The deeper you go into gravity, the stronger the effect. Near the surface of Earth, time runs a tiny bit slower than it does in orbit. But near a black hole, the difference becomes extreme. To a distant observer, time around a black hole appears to freeze. To someone falling in, time passes normally. This strange stretching of time means black holes may act like natural time machines, carrying travelers into the far future. But what about going backward? That question pushes physics into even stranger territory. General relativity allows for the theoretical existence of wormholes, tunnels through space-time connecting two distant points. If one mouth of a wormhole were accelerated close to the speed of light or placed in a strong gravitational field, time would flow differently on each side. Step into one mouth, and you could emerge not only in another place, but perhaps in another time. The catch is that wormholes are unstable. They would collapse instantly without being propped open by something exotic. Negative energy or exotic matter. Quantum physics hints that such energy may exist in fleeting bursts, but whether it can be sustained is unknown. Still, the mathematics suggests the possibility. Another idea comes from cosmic strings, hypothetical defects in space-time left over from the early universe. If two cosmic strings passed one another at high speed, they might bend time enough to form closed loops. Such loops, known as closed time-like curves, could in principle allow travel to the past. But again, this remains speculation. With no evidence cosmic strings even exist. Even if backward time travel were possible, paradoxes loom. The grandfather paradox asks, what happens if you go back and prevent your grandparents from meeting? If you erase your own existence, how could you have traveled back in time at all? Another is the bootstrap paradox, where information has no origin. Imagine receiving a blueprint for a time machine from your future self. You build it, then hand the plans back to your past self, who then invented the machine. Such puzzles strain not only physics, but logic itself. To resolve this, some scientists propose the principle of self-consistency. The universe prevents paradoxes by forcing events to play out in ways that avoid contradictions. In other words, even if you traveled to the past, you could not change it. Your actions would already be woven into history. Others suggest the multiverse theory. Each choice spawns a new branch of reality. Go back in time, kill your grandfather, and you don't erase yourself. You simply shift into a new universe where you were never born. Quantum physics adds more intrigue. At the subatomic level, particles behave in ways that defy common sense. They can exist in multiple states at once, only collapsing into one when observed. Some theories suggest time itself may be similarly fluid, perhaps even allowing for loops or reversals under exotic conditions. Could the key to time travel be hidden in the quantum realm? We don't know, but the questions continue to drive research. And in a sense, time travel is already happening. Astronauts aboard the International Space Station orbit Earth at high speeds, in weaker gravity than we experience on the ground. As a result, their clocks tick just a little slower. When they return, they are microseconds younger than their Earth-bound twins. This effect is tiny, but it proves that traveling through time is not just science fiction. It is a measurable fact. The challenge lies in scaling it up. To send someone a century into the future, we would need near light-speed travel, demanding energy far beyond anything humanity can currently generate. To send someone into the past, we would need wormholes or cosmic strings, stabilized by physics we have yet to discover. Still, the dream endures, because time travel is not only about physics. It is about longing. We dream of revisiting moments lost, of seeing people we miss, of undoing mistakes. We dream of leaping forward to witness humanity's future, to see how our story unfolds. These dreams reveal something profound. Time is not just a scientific mystery. It is personal. It defines us, our choices, our mortality. Even if time travel never becomes practical, the search to understand it has already reshaped science. Einstein's thought experiments gave us relativity, which gave us modern technology. The exploration of time has led us to discover black holes, quantum physics, and the accelerating expansion of the universe. The pursuit of time travel may never yield a machine, but it already yields knowledge. Perhaps time is less like a flowing river and more like a vast landscape. The past, present, and future all exist at once. We simply move through it, moment by moment, like travelers across terrain. If that is true, then perhaps time travel is not about changing the past or leaping ahead, but about learning how to step off the path and explore the landscape more fully. For now, though, we remain bound to the arrow of time. It carries us forward, never back, at 1 second per second, but the dream persists. Because in the end, time is not just something we measure. It is the canvas on which the universe paints its story. And perhaps one day, with deeper understanding, we will learn not only to tell time, but to travel it.